Today in math practice we are going to discuss the chapter Quadrilaterals of class 9. This is a one-shot video which will cover the entire chapter with all the important examples. So watch the video till the end and subscribe to math practice. Some definitions. A quadrilateral is a closed shape and a type of polygon formed by joining four non-collinear points. If there are four non-collinear points, you join them, you get a quadrilateral. So a quadrilateral has four sides, four vertices, two diagonals, and remember the sum of its angles is always 360 degree. Now there are some types of quadrilaterals which you need to know. First one is trapezium or trapezoid, parallelogram, squares, rectangle, rhombus, and kite. This shows all the properties of all the types of quadrilaterals. So please remember these properties. They are very useful in answering the MCQs. First is square, which you know it has four equal sides and opposite sides are parallel. All the angles in a square are of 90 degree. Diagonals bisect each other. Diagonals are of the same length and diagonals meet each other at 90 degree right angle. Second is rectangle. Two pairs of equal sides and opposite sides are parallel. All angles are 90 degree. Diagonals bisect each other and they are of same length. Parallelogram. Two pairs of equal sides, so opposite sides are parallel. Two opposing pairs of equal angles. Opposite angles are equal in parallelogram. Diagonals bisect each other. Rhombus. It has four equal sides, opposite sides are parallel, two opposing pairs of equal angles. Diagonals bisect each other and also diagonals bisect each other at 90 degree. Then you have kite, two pairs of equal sides, one opposing pair of equal angles. Only one pair of opposite angles are equal. Diagonals meet at right angle. Trapezium. One pair of parallel sides, no equal angles, no special properties for diagonals right now. Isosceles trapezium. It is a type of trapezium in which one pair of equal sides and one pair of parallel sides. So the non-parallel sides are equal. Angles for isosceles trapezium, two pairs of equal angles and diagonals bisect each other and are of same length. We are going to prove some properties for different type of quadrilaterals, but before that, please keep this diagram in mind. It will be helpful to answer the objective questions. Quadrilaterals are basically two types. One is parallelogram, another is trapezoid or trapezium. For trapezium, there is only one pair of parallel sides. Now you have parallelogram in which opposite sides are parallel, opposite sides are equal, opposite angles are also equal and diagonals bisect each other. Now from parallelogram you have other three types of quadrilaterals. First is rectangle. So rectangle is already a parallelogram. In addition to that, all angles are equal and they are equal to 90 degree. And equal diagonals bisect each other. The diagonals are equal. Now square. Square is already a parallelogram. So all sides are equal. All angles are equal to 90 degree. Equal diagonals and the diagonals bisect at 90 degree. What is a rhombus? A rhombus is already a parallelogram in which all sides are equal and diagonals bisect at 90 degree. So try to remember this diagram. It will be really helpful. These are some objective questions which are based on the properties of quadrilaterals we have just seen. As I told you, the previous tree structure which we have seen, that will make it very easy for you to answer these questions. So please answer these objective questions. Theorem 8.1. A diagonal of a parallelogram divides it into two congruent triangles. Let us try to prove this theorem. First you have a parallelogram ABCD and AC is one of its diagonal. We have to prove that it divides it into two equal congruent triangles. Now first of all, the diagonal divides into two triangles, triangle ABC and triangle CDA. We have to prove they are congruent. Now for both these triangles, if you see, BC is parallel to AD, it is a parallelogram, and AC is a transversal. So BC is parallel to AD, and if AC acts as a transversal, angle BCA and angle DAC, you can see they are pair of alternate angles, so they are equal. Also now AB is parallel to DC and AC acts as a transversal. So in this case angle BAC will be equal to angle DCA, because again they are pair of alternate angles. AC and CA same side. So by ASA rule we have shown that triangle ABC and triangle CDA are congruent. Some important theorems on parallelogram which give you the necessary and sufficient conditions for being a parallelogram. Theorem 8.1, a diagonal of a parallelogram divides it into two congruent triangles. 8.2, in a parallelogram opposite sides are equal. 8.3, if each pair of opposite sides of a quadrilateral is equal, then it is a parallelogram. So it is the converse. Theorem 8.4, in a parallelogram opposite angles are equal. Conversely, if in a quadrilateral each pair of opposite angles is equal, then it is a parallelogram. Theorem 8.6, the diagonals of a parallelogram bisect each other. Conversely, if the diagonals of a quadrilateral bisect each other, then it is a parallelogram. Hence, if you have a quadrilateral, it is a parallelogram if a pair of opposite sides is equal, and even if one pair of opposite sides is equal and parallel. Let us start with the first example. Show that each angle of a rectangle is a right angle. Now, by definition, a rectangle is a parallelogram in which one angle is a right angle. ABCD is a rectangle with angle A 90 degree. We have to prove all three other angles are also right angles. We are given that AD is parallel to BC, and you can see that AD is parallel to BC, so AB can act as a transversal. Now interior angles on the same side of the transversal form a linear pair, so angle A plus angle B is 180 degree, but angle A is 90 degree, so angle B will also be 90 degree. Similarly, angle C and angle A will be equal, and angle D and angle B will be equal opposite angles of the parallelogram. So angle C will be 90 degree and angle D will also be 90 degree. Hence all the angles of a rectangle are right angles. Example 2. Show that the diagonals of a rhombus are perpendicular to each other. Consider the rhombus ABCD. Rhombus means all the sides are equal, so AB, BC, CD and DA are equal. Now in AOD and COD, triangle AOD and triangle COD, OA is equal to OC because diagonals of parallelogram bisect each other. Rhombus means first it is a parallelogram also, so diagonals bisect. OD and OD same common ray line segment. AD is equal to CD again because sides are equal in a rhombus. Therefore, triangle AOD, triangle COD are congruent by SSS congruence rule. By CPCT, angle AOD and angle COD are equal. But obviously, both of them form a linear pair, so the total is 180 degree. Hence, both the angles are of 90 degree. Hence, angle AOD is 90 degree, or we have shown that the diagonals of a rhombus are perpendicular to each other. Now, example 3. ABC is an isosceles triangle in which AB equal to AC, AD bisects exterior angle PAC, and CD is parallel to AB. Show that first thing angle DAC and angle BCA are equal, and second thing ABCD is a parallelogram. First of all, let us try to understand the diagram. Triangle ABC is isosceles in which AB is equal to AC. Two sides are equal. Now we know that if two sides are equal, angle opposite to them will also be equal. So angle B and angle C will be equal. Now if you see angle PAC, it is the exterior angle. So angle ABC plus angle ACB will be equal to angle PAC, because we know that the exterior angle will be the sum of the two interior angles for that triangle. So angle PAC is equal to angle ABC plus angle ACB. Therefore, we can now write angle PAC is equal to 2 times angle ACB because ACB and ABC are equal. Let this be first statement. Now AD bisects angle PAC. This is given to us. So it means that angle PAC is 2 times angle DAC. Let this be statement 2. From 1 and 2 we can say that angle 2 times angle DAC is equal to 2 times angle ACB, or in other words angle DAC is equal to angle ACB. Now we want to prove that ABCD is a parallelogram. We have already proved angle DAC is equal to angle ACB and they form an alternate pair of angles where line segments BC and AD are intersected by a transversal AD. Now we have the result that if alternate pairs are equal, then the lines are parallel. So BC is parallel to AD. Also BA is parallel to CD. This is given to us. So now both pairs of opposite sides of quadrilateral ABCD are parallel. Hence ABCD is a parallelogram. Next example. All the examples are of different types, so try to understand them. Show that the bisectors of angles of a parallelogram form a rectangle. So first of all, let PQRS be the points of intersection of the bisectors of angle A and B, angle B and C, angle C and D, and angle D and A respectively for a parallelogram ABCD. So just look at the diagram. Now in triangle ASD, since DS bisects angle D and AS bisects angle A, so we can now write angle DAS as a half of angle A and angle ADS as half of angle D. So we have this is equal to half of angle A plus angle D. But angle A and angle D, they are the interior angles on the same side of the transversal. So the sum is 180 degree. So angle A plus angle D is 180 degree. Hence half of 180 degree is 90 degree. So what we have shown is angle DAS plus angle ADS, that is equal to 90 degree. Now we know that by the angle sum property of a triangle, the sum of the three angles of a triangle is 180 degree. So angle DAS plus ADS plus DSA is 180 degree. But already we have shown ADS plus SAD, they are equal to 90 degree. So the third angle, angle DSA, will be equal to 90 degree. Now angle PSR is vertically opposite to angle DSA. So it will also be 90 degree. So we have shown that angle PSR is 90 degree. In the same way, we can show that angle APB is 90 degree, but that is same as angle SPQ. Similarly, angle PQR, or you can say angle SRQ, both are 90 degree. Now, what you have over here is all the four angles PSR, PQR, SPQ and SRQ. All the four angles are 90 degrees. So PQRS is a quadrilateral in which all angles are right angles and hence it is a rectangle. Next example, example 5. If AN and CP are perpendiculars to the diagonal BD of a parallelogram ABCD, then prove that first thing triangle ADN is congruent to triangle CBP, and second thing AN is equal to CP. Now let us see what is given to us. We are having ABCD, which is a parallelogram. That means AD is parallel to BC. And here BD is the transversal. Now we have perpendiculars AN and CP. ADN and CBP, angles ADN and CBP, they are alternate interior angles. So they will be equal since parallel lines are there, BD is a transversal, so alternate interior angles are equal. That means angle A and D and angle BPC, angle A and D and angle BPC, they both will also be right angles. Why? Because we have drawn perpendiculars, so they are right angles. Also AD is equal to BC, opposite sides of parallelogram. So by AAS congruence rule, triangle ADN and triangle CBP will be congruent. Now by CPCT, AN will be equal to CP. Hence, we have shown that both the triangles are congruent and AN is equal to CP. The perpendiculars are equal. Next example. Find the measures of all angles of a parallelogram if one of the angle is 24 degree less than twice the smallest angle. Now, suppose the smallest angle is over here of measure x for the parallelogram. Now we know that two opposite angles will be equal. So sum of the two opposite angles will be 2x. The other angle is 24 degree less than twice the smallest. So 2x minus 24. So now the other two angles will be, the sum of other two angles will be 2 into 2x minus 24. And sum of all the four angles is 360 degree. So when we solve this equation, we get x is 68 degree. So two opposite angles are 68 degree. The other two opposite angles will be 2 into 68 minus 24, which is 112 degree. So the measures of four angles are 68 degree, 112 degree, 68 degree and 112 degree in that order. Example 7. Show that the diagonals of a square are equal and bisect each other at right angles. So we are given over here that ABCD is a square, AC and BD are its diagonals and they are intersecting at O. We have to show that the diagonals are equal and they bisect each other. That means we have to show AO equal to OC and also they bisect at right angles, means angle AOB is 90 degree. So three things have to be shown. First of all, diagonals are equal, diagonals bisect each other and bisect each other at right angles. So now consider triangle ABC and triangle BAD. Triangle ABC and triangle BAD. So AB is equal to BA, common arm. Angle ABC and angle BAD both are 90 degree because it is a square. So it is given. Same way BC is equal to AD. BC is equal to AD because square. So by SAS congruency, ABC and BAD are congruent. Hence by CPCT, AC will be equal to BD. So first part is simple. Just consider two triangles in this square. Prove that they are congruent and by CPCT the diagonals are congruent. So we have first thing shown that diagonals are equal. Second thing, we have to show that the diagonals bisect each other. Means if AC is the diagonal, AO and CO are equal. This is what we have to show. Now in triangle AOB and COD, we have angle BAO and angle DCO. They are alternate interior angles. So they will be equal since square, so the sides are parallel. So the alternate interior angles are equal. AOB and COD, they are vertically opposite angles, so they are equal. Same way AB is equal to CD. It is a square, so sides are equal. So by AAS congruency, again AOB and COD are congruent. So by CPCT, AO is equal to CO. So diagonals bisect each other. Third thing we need to show is diagonals bisect each other at right angles. So we have to now show that angle AOB is equal to angle COB and both are 90 degree. So now consider triangle AOB and COB, AOB and COB. In that OB equal to OB, same side. AO is equal to CO. Diagonals are bisected. Just now we have shown. AB is equal to CB. The sides of the square are equal. So by SSS congruency, AOB and COB, they are congruent. So by CPCT, both the angles AOB and COB will be equal. But AOB and COB, they form a linear pair. So total is 180 degree. Both are equal. Total is 180 degrees. So both are of 90 degree. So we have shown that diagonals bisect each other at right angles. In these type of examples, first figure out what has to be proved and accordingly consider the congruency. Now example 8. ABCD is a trapezium in which AB is parallel to CD and AD is equal to BC, isosceles type of trapezium. Show that angle A and B are equal, angle C and D are equal, triangle ABC and triangle BAD are equal, and diagonals AC and BD are equal. We will try to prove one by one each of them. First thing is how the construction is done. Draw a line through C parallel to DA intersecting AB produced at E. So see the diagram. Now CE is equal to AD. Why? Because how we have done the construction, accordingly ADCE is a parallelogram and opposite sides of parallelogram are equal. So CE equal to AD. Already AD equal to BC is given. So now we have CD is equal to AD and that AD is equal to BC. So basically BC and CE are now equal. So first thing we showed that BC and CE are equal. Now if the sides are equal, angles opposite to them will also be equal. So angle CBE will be equal to angle CEB. Now just see the diagram. Angle A plus angle CEB, it is equal to 180 degree. Why? Because AD is parallel to CE and angles on the same side of the transversal, they form the linear pair. So angle A and angle CEB total is 180 degree. But instead of CEB, we can write CBE because just now we have shown that they are equal. So now we have angle A plus angle CBE is 180 degree. Also angle B and angle CBE, they form a linear pair. So their sum is also equal to 180. So now from the first and second point, we have shown that angle A and angle B are equal. We have shown angle A and angle B are equal. Now we need to show that angle D and angle C are equal. Now angle A plus angle D is equal to angle B plus angle C. And both of them are 180 degree. They form a linear pair because same side of the transversal. So now angle A plus D is equal to angle A plus C. Why? Because instead of angle B, I can write it as angle A. So now this gives us angle D is equal to angle C. Now to prove the third part, we want to establish the congruency. So consider the triangles ABC and BAD. AB is equal to AB, the common arm. From the first part, we have shown that angle BAD and angle ABC, they are equal, correct? Now also AD equal to BC is given to us. So by SAS congruency, triangle ABC and triangle BAD are congruent. And by CPCT, the diagonals AC and BD will be equal. Now some facts about triangle. Theorem 8.8, which is the important midpoint theorem. It says that the line segment joining the midpoints of two sides of a triangle is parallel to the third side. Also the converse of midpoint theorem, theorem 8.9 says that the line drawn through the midpoint of one side of a triangle parallel to another side bisects the third side. That means suppose if you are having triangle ABC, E and F are midpoints of AB and AC respectively, then if they are the midpoints, then EF and BC will be parallel. And conversely, if EF is parallel to BC, then EF will be half of BC. Let us see how these theorems are useful in solving the examples. Next example. In triangle ABC, D, E and F are respectively midpoints of sides AB, BC and CA. Show that triangle ABC is divided into four congruent triangles by joining D, E and F. Try to do all these type of examples. They are really important. Now we already have D and E. They are the midpoints of AB and BC of triangle ABC. So just by theorem 8.8, for the third side, DE will be parallel to AC. Similarly, DF will be parallel to BC and EF will be parallel to AB. Therefore, we have ADEF, BDFE and DFCE. All of them are parallelograms. Now, DE is a diagonal of the parallelogram BDFE. Therefore, again by the theorem 8.1, triangle BDE and triangle FED, they will be congruent. Similarly, triangle DAF and triangle FED will be congruent and triangle EFC and triangle FED will be congruent. Hence, all the four triangles will be congruent. Example 10. ABCD is a rhombus and P, Q, R and S are midpoints of side AB, BC, CA and DA respectively. Show that the quadrilateral PQRS is a rectangle. Now we are given that ABCD is a rhombus and PQRS are midpoints of the four sides. We want to prove that PQRS is a rectangle. So first thing is we join AC and BD. Now in triangle DRS and BPQ, triangle DRS and BPQ, we have DS is equal to BQ and DR is equal to BP. Why? Because all sides of the rhombus are equal. So you have the midpoint, so their halves will also be equal. Now also angle SDR and angle QBP, they are opposite sides, opposite angles, so they will be equal. So by SAS congruency, DRS and BPQ are congruent, and by CPCT, RS and PQ are equal. So first thing we have shown is RS and PQ are equal. Like we showed that PQ is equal to SR, similarly by SAS congruency we can show that triangle QCR and SAP are congruent, and hence QR is equal to PS. Now in triangle CDB, R and Q are midpoints of CD and BC respectively. So by the theorem 8.8 we have that QR will be parallel to the third side, which is BD. So QR is parallel to BD. Similarly, P and S are midpoints of AD and AB. So again by theorem 8.8, PS will be parallel to BD. QR is parallel to BD, PS is parallel to BD. So QR and PS will also be parallel. So hence what we have shown is QR is parallel to PS. Now PQRS is a parallelogram. So angle PQR will be equal to 90 degree. This is by the property of rhombus, because ABCD is a rhombus. So PQR will be 90 degree. So in quadrilateral PQRS, what we have shown is the opposite sides are equal, RS equal to PQ and RQ equal to SP, and also one of the angle is a right angle, and hence this is sufficient to prove that PQRS is a rectangle. We are discussing all the different types of example. Example 10. In a parallelogram ABCD, E and F are the midpoints of side AB and CD respectively. Show that the line segments AF and EC trisect the diagonal BD. So now first of all, see what is given to us is ABCD is a parallelogram. E and F, they are midpoints of AB and CD respectively. Now what we have to show is AF and EC, when you join them, they trisect the diagonal BD. Trisect the diagonal BD means we have to show that PD, PQ and QB, all the three are equal. Now what is given? AB is parallel to CD, because ABCD is a parallelogram. So obviously AE will be parallel to FC. Now AB is equal to CD, because opposite sides of parallelogram are equal. So half AB will be equal to half CD. But what is half AB? Half AB is AE and half CD is FC. So AE is equal to FC. So now for AECF, you have AE is equal to FC. Also you have shown that AE is parallel to FC. So AECF is a parallelogram. Correct? As AE and CF are parallel and equal to each other, AECF is a parallelogram. Now opposite sides of a parallelogram are parallel. So AECF we have just now shown is a parallelogram. So AF and EC will be parallel. In triangle DQC, F is the midpoint of DC and FP is parallel to CQ. So again by the converse of midpoint theorem, P should be the midpoint of DQ. So P is the midpoint of DQ, means DP is equal to PQ. Similarly, now consider triangle APB. In triangle APB, EQ and AP are parallel. Q is the midpoint of PB. Why? Because again by converse of midpoint of theorem, since the two lines are parallel over here, Q is the midpoint of PB. Hence PQ is equal to QB. So what we have is DP is equal to PQ and PQ is equal to QB. So DP, PQ and BQ, all the three are equal. So what we have shown is the line segments AF and EC trisect the diagonal BD. Now some assignment examples. Please solve these assignment examples. In a parallelogram, prove that opposite sides are equal. The hint is you can use the theorem 8.1. What was theorem 8.1? The diagonals of a parallelogram divide the parallelogram into two congruent triangles. Now second one, the sum of angles of a quadrilateral is 360 degree. Again by congruency you will be able to prove this. Third one, if the diagonals of a parallelogram are equal, then show that it is a rectangle. Here by SSS rule you will be able to establish the congruency, which will give you by CPCT angles A and B to be equal. Fourth one, show that if the diagonals of a quadrilateral are equal and bisect each other at right angles, then it is a square. So first of all you have a quadrilateral and the diagonals are equal, and suppose they are intersecting at O, they bisect each other at right angles, correct? Then the hint is prove the congruency between triangle AOB and COD, and same way AOD and COD by SS congruency. Then you will be getting it as a square. Fifth one, the line segment joining the midpoints of two sides of a triangle is parallel to the third side. Midpoint theorem. How are you going to prove this? If E and F are midpoints of triangle ABC, produce CD which is parallel to B, and then by ASA congruency you will be able to prove that BCD is a parallelogram. Next assignment example. Let L and M and N be three parallel lines intersected by transversals P and Q such that L, M and N cut off equal intercepts AB and BC on P. Show that L, M and N cut off equal intercepts DE and EF on Q also. First draw the diagram. The hint is the trapezium ACFD is divided into two triangles, triangle ACF and triangle AFD, and then use the theorem 8.9, converse of midpoint theorem. Seventh one, ABCD is a rectangle and PQRS are midpoints of the sides AB, BC, CA and DA respectively. Show that the quadrilateral PQRS is a rhombus. Hint is PQ will be half AC, same way SR half AC by midpoint theorem. PQ is parallel to SR and PQ is equal to SR, which will give you PQRS as a rhombus. Eighth one, ABCD is a trapezium in which AB is parallel to DC, BD is a diagonal and E is the midpoint of AD. A line is drawn through E parallel to AB intersecting BC at F. Show that F is the midpoint of BC. What is the hint? G is the midpoint of BD and GF, AB, DC are parallel. So F is the midpoint of BC, and this is by the converse of midpoint theorem. Please solve all the assignment examples. In case of any query, please put in the comment section. We have tried to cover many examples from this chapter quadrilaterals. So please do practice these examples. Do like and share the video and subscribe to Math Practice.